means like you want to make a groove like this, which is say a hole like thing, but it is not a hole, it is a groove. Why? Because it is a straight groove or some cylindrical, some shape may be possible. Similarly, cutting with form tool is something like you want to have a form like a forming or a shape like a wave like thing. It is not a thread is different. So this is only a shape. Thread is a helical thing. It is a continuous thing. This is not a continuous. This is a cutting of a form. Suppose the form here shown is some wave-like thing. You can have a V groove. You can have a square groove, square wave. This shape need not be as smooth as this. This can be on any groove tool. And then boring. Boring means enlarging a existing hole. Anyway, boring we also discuss in this class again. This is one variety possible, and then drilling is possible. Means drilling means making hole. So this is also possible with the lathe in some operations. Cutting off means making the part into two pieces, and then threading. This is what actually threading. Threading is a helical thing, which is a continuous thing. And then knurling. This is called knurling, where some design is engraved with a special tool onto the surface of this. This knurling we find in say at the end of say any object for a better grip, like your screws or some objects which we require a better grip at the edge. So we knurl. We use an operation called knurling for better grips to say something like screws or some object, any object which you want to have a better hold. So we may use a tool called knurling tool to make that object having this shape engraved. This is only to improve the gripping action on the tool, on the workpiece. So this is how these some operations that are possible with the lathe. Many more operations are there. They are called accessory. Whenever there is a need, then we go for that. So actually lathe is the main operations of that is straight turning, taper turning, profiling, facing, threading are the major things. The remaining are as and when it is required, we go for that. So this is what we have in the previous class. Now we will move to the next type of machine or next type of machining operation. So still any people are still, how many people are here? 60 people. Okay. So we continue our discussion. So as we were discussing this, now let us say the another type of machining operation is shaping. So this is the new another machine. So the workpiece here, what is the difference between shaping and the turning operation or the lathe operations is, lathe is basically for a cylindrical objects to be machined or to be shaped. So the workpiece there in case of a lathe is most generally a cylindrical orientation. Whereas in the shaping, the process to plane the surface of the workpiece is to reduce the part thickness is the major operation for the shaping. So here the metal removal rate is okay, higher, but medium surface finish and dimensional control is also good. So what is it look like this? It look like a shaper looks like this, which is having a slider which moves move forward and backward. I mean oscillates, which oscillates or which reciprocates. Perfect word is reciprocating, moving forward and backward. So it reciprocates. The slide moves forward and backward, and then this is a pivot, and this one is the tool at which we have similar tool as that of the lathe, that is a single point tool. So this tool, when it is moving, when this is moving forward, so it removes the chip, as we see in the previous metal cutting introduction, fundamental machining thing, where the tool is pressed against the workpiece, which causes the shearing action, and then chips are formed. So that is how a chip is formed here. So, and then while moving forward, while moving out, it removes the chip, and then as it passes the workpiece, there is no, then it has to go back. So this is called return stroke. So return stroke, that means you see here during the forward stroke, as we see the direction of arrow here, during the forward stroke, it removes the material. During the return stroke, it is idle stroke. It is not removing any material because the tool is in the forward direction. So while it is going back, it will not remove any material. That is called idle stroke. So here in this shaping, normally what is the time required to go forward is, say for example, to cut or to move from this point to the end point, say 2 seconds. So can if it takes 2 seconds to move forward, how much time it takes to come back to original position again? So can anybody tell me what is the if it takes 2 minutes to go forward and then it comes back? So what is the total time for cycle? Cycle means starting from one place to going forward and coming back. So that is one cycle. So if forward stroke takes 2 seconds and coming back also, how much time it takes? Same time or more time or less time? Can anybody tell me if it is reciprocating forward and backward, the shaper that is shown in that figure? Less time, why? How? Less time, how, Mr. Wang? How less time? Normally, if you go from say from one place to other place and coming back to that place to original place, it takes same time. Normal, if you work as a normal machinery or normal, because we are not changing any speed. So Mr. Wang is correct. Hamdan is also correct. Less time. How why less time? How less time? Because we adopt some mechanism. No cutting involved is not the answer. No cutting involved because of not because the whether it is cutting or not cutting, it is the velocity is same. Velocity, when as long as velocity is same, it will not have less time. It is time depends on velocity. If it is moving with some velocity, it is coming back with the same velocity. Whether it is cutting or not cutting, it doesn't matter. It takes same time. But here because here comes the what we call it as a quick return motion mechanism. Quick return motion mechanism. So quick return, it returns quickly. How? Because we adopt a machine. This thing you learn in mechanisms of machines, probably next semester. So that is called quick return motion mechanism, which is involved here, where we adopt a mechanism called, normally in a crankshaft movement, if it is moving with some velocity, it will come back with the same velocity. But here we will make an arrangement called quick return motion mechanism with the help of a special mechanism. That is to reduce the return stroke. Why we want to reduce the return stroke? Because in the return stroke it is not taking any cut, so it is a unproductive time. So if 50% is productive time, another 50% is unproductive time, then obviously the machining time is more. So we want to reduce machining time. That means by reducing unproductive time. So this unproductive time, we increase the speed of the return stroke. So that is possible. Increase the speed of the return stroke. We don't increase manually. We adopt a mechanism which facilitate us to have more time for cutting, less time for return. It will not adjust actually the speed. It will it will adjust is it will adjust the time, so that more time is in participating the cutting, less time in what you call idle time. So that is how the mechanism works. That is called quick return machine mechanism. I am not going here because we are not discussing mechanisms. Anyway, that is a very good mechanism which we have to study in our mechanics of machines. So before I show the actual machine, I will show the quick return mechanism just as a physical thing, but I'm not going to give you the mechanism, how it works, and those criteria we will learn there. So any questions? Somebody, is there any question waiting? No cutting involved. Quick return motion mechanism. Yes. So we go there again. Any questions? So no questions means let me show you the mechanism on the how the shaper works actually. So let me show you the video. Then you have any questions? We will take. Mr. O, you switch off your mic. Mute your mic. Yeah, let us see the shaping mechanism. Actual shaper is something like this, which is shown here. This is the reciprocating arm, and here you have. So here you have the tool post. This is the tool post to which you attach a tool, and your workpiece is on the vise. This is vise, which is to fit the workpiece. So workpiece is here, and your tool is here. So this one is reciprocating forward and backward, and this is the actually the plate is removed to show quick return motion mechanism. So the levers, how they work. So let us say what is happening and how it works. Let us see. So here you see the shaper is reciprocating. That means the arm is. So this is the one which is rocker arm like thing. This is called quick return motion mechanism. So you see, because our intention in this class is machining. So let us watch the machining. This is the a quick return motion mechanism. This is a slotted lever, and then we have a crank and rocker mechanism. But that link and time, everything you will learn in mechanisms class. In the shaper machine, actual work is this. Actual work is this, and actual tool is here. It is not very visible because it is very small tool which is attached there. This one is tool post. Actually, this big broad one is actually tool holder. So this tool holder, and then tool head. This is called tool head, and this is the one which is. So you see here, this is the closest view. The closest. This is the tool which is here, and then the work is here. So this is the reverse motion. It is not taking. One which is he is adjusting here is the what is called feed rate. That means the tool has to move along this direction. That means along the say for example, the reciprocation is x-axis, the other side is y-axis. So it has to move y-axis to cover the area, entire area of the entire surface of the cutting. So that is the feed given by automatically or by hand. which is changing is the feed rate that is given. The reciprocating is depth of cut. You can see here, this is just you can zoom it now. So maybe even zoom also, maybe you may not be able to see. Let us continue over. So this one is, so now the tool is visible. Here this is the tool, which is a single point tool, as we see in our lathe. So it cuts during forward stroke. So it cuts. And then when it is coming, it will not cut anything, because when it is, so this is how it works. So if it is, this is a quick return motion. So here you see, you can also keep the tool at some angle. So that is the one which is given here. Tool can be tilted with a slight angle, because in some cases we want machining like a V groove. Then we will make the tool in a in a tilted shape, 45 degrees, 30 degrees, whatever groove you want. For that type of workpieces, we tilt the tool to make the required groove of 30 degrees, required groove of 15 degrees, like that. So here it is cutting a flat surface. So can you tell me what is the difference between the lathe and the shaper? What observation you made? Any observations between lathe and the shaper? Or what is the limitation of the shaper? If you see, the when you come, you just now we listed a few operations by the lathe. So this is different than the summary slide which we have in our lathe, is it not? So any other difference? What is the uh, good, or what is the specialty of the shaper? Are you able to hear me? Are you getting sound, or it is stopped? Lathe is for uniform circular cut or shaping. Shaper only smooth or cut straight surfaces. Yeah. So yes, to the extent you are correct. Here, the if you see, lathe is it can also work for small, what you call, flat surfaces. Lathe can be, but for big objects it cannot. For whereas shaper is a specialized machine tool for flat surfaces. For example, in the shaper, You cannot have other operations which we mentioned in the. It is not shaper is not same as milling, but milling can do all shaping operations. But shaper has certain specialty works. That is why shaper is existed. Otherwise, the shaper might have extinguished. For why it is existed? Because milling can also do what the shaper can do, but shaper can do some peculiar operations, which I said is some V groove or cutting a slot at a narrow thing. Those things are good. And then milling machine, though it can do, we will discuss milling at a later stage. But as you have seen in the lab, so you have some idea about milling, but milling function is a more versatile like lathe. Lathe and milling are more versatile machines which can perform a variety of tasks, not only single task. Whereas shaper is a single task, that means specialized machine for flat surfaces to machine flat surfaces and also making grooves, slots, slot cutting, uh, those type of operations. So that is why shaper is a specialized machine to machine flat workpieces, flat surfaces with a better surface finish. The flat can also be worked by milling, but milling is, as I said, a versatile machine, and also it has some limitations over cutting the grooves, etc. So here the shaper can perform flat surface and grooving on the flat surfaces. So that is why we require a shaper. Uh, if it is suppose in the milling machine also or lathe machine also, very big machine, very big plate. For example, we want to have machining of some 1 meter plate, 1 meter by 1 meter plate, big platform, say a surface plate or a body of a some big object, then you cannot load that big object onto the lathe or onto the milling machine, because very big objects, say as I said 1 meter, 1 meter by 1 meter uh, flat plate. You cannot machine 1 meter by 1 meter flat plate on a milling machine or on a shaper. Only shaper also it is possible to some extent, but beyond that shaper, there is one more machine which is similar to shaper, which is called planer. Let us see what is the planer and how it works. Then you tell me what is the difference. So another thing compared to the just now we had seen the shaper. So shaper is, you see the tool is reciprocating and cutting the material. As I said, this one, as we show here, it is a small vice is shown because it is a lab model. So if you have the big vice, then you can have big workpiece which is having say half-meter or half-meter, something like that. You can accommodate on this machine because the this machine capacity is defined by length of the stroke. Length of the stroke is say 50 centimeters, so you can machine 50 centimeters lengthwise workpiece on this shaper. Similarly, suppose as I said, in normal cases we want very big objects which are to be machined, like 1 meter, like table, like your surface plate in the lab. So that means you want to machine this kind of suppose this bottom one. This bottom one, there is one structure. If you want to machine this structure, you cannot machine either lathe or any other machine. So we have to machine this kind of the one which is at the bottom. Okay? Which I showed where the cursor is moving. So this kind of this bottom structure, if you want to machine, not possible with our machines. So for this, there is a machine called planing. We see what. So planing and shaping are similar operations, which differ in the kinematics. So they differ in the kinematics means planing is a machining operation which primarily cutting motion is performed by the workpiece, and the feed motion is imparted to the cutting tool. Earlier in the previous shaper case, we have seen that the tool is moving forward and backward. That means that is the depth of cut given to the depth of cut is given to the tool, as well as feed rate. Feed rate means side movement also is given to tool. Whereas in the planar, it is vice versa. It is a different thing. In the planar, workpiece and feed motion is important to the cutting tool. In shaping, the primary motion is performed by the tool and the feed is to the workpiece. So that means depth of cut, the feed is given to the table there. Here both are on the workpiece. So how is it? Let us see shaping. Uh, you observe the figure. Later I will ask what is the difference. So what is the difference between figures? You observe and tell me what is shown there. It is the as far as the mechanics is concerned, like tool is here, work is here, and it's removing. Tool is here, work is here, and it's removing. So if you see the tool chip interface is exactly same for shaping and planing. Then what is the difference? What is the difference? Observe and tell me. So in the diagram itself, they mentioned something, and also description it is mentioned. So what is it? The difference? The difference is what? What difference you observed from the figure? It's already mentioned there. So if you don't understand what is it, let me show you one animation on planing. Then you can understand. Okay? What is happening there? What is happening? So how big is planer? Planer is a very big machine, which is of, as I said, few meters. You can have a workpiece of few meter length, few meter width, few meters height. So that big items can be handled by planing. But of course, it is only the name itself is indicating planar, plane surfaces only can be machined. So, but if it is a very big objects can be machined. So, if you look at this, the differences here on the figure, and then I will show the animation. The difference is the difference is the tool is moving here in the shaper. Cutting speed is given to the tool, whereas here the work is moving. Tool is stationary. So this is basic relative motion difference. Cutting speed or cutting tool is moving, whereas in the planar, tool is stationary, cutting speed is given. In the case of speed is again relative. Workpiece is forwarded to change. Suppose this is machining here, machining here, machining here, machining here. This is happening because we are feeding this, whereas here we are feeding the tool, not the work, because work is very big. We cannot move. It is a very big size. So let me show you some animation on the planing also. Then you can see the differences between planing and shape. So you see here the planing machine is having a big table, and on this big table you have the big tool head, so to which the tool is attached. Remaining here, there also forward stroke is only taking cut, reverse stroke is not taking cut, but you can make it taking the cut in the case of planar. In the case of planar, you may mount two tools. One is for forward cutting, another for reverse cutting. Because we don't here normally adapt quick return motion. It is just you see here there is a belt drive, and then this is the power is transmitted to the wheels, and the wheels are moving this thing to forward and back. Let us see what is that. So you can see here the parts are identified. So this is called bed, planar bed, on which table is mounted. On the table, we mount or we fix the work which we want to do. So this one is the cross head, which can be movable, give the feed rate. So this is how what is given there in the previous comparative picture. Tool is moving, work is stationary. Tool is moving what? Tool is moving feed rate. That is slides moving sideways. Suppose in this case, suppose this is workpiece, suppose this plate, big plate, white plate, for example, is aluminum plate. So this is the work plate. So but this big plates cannot be handled by other machines. So then we have to go for planar only. So this is work and this is tool. So as we see here, so here this is forward stroke. You see in the forward stroke, now the work is moving against the tool. So in the return stroke here, only one tool is fixed, so there won't be any metal cutting. Just it is going idle because the tool is in the other form, so it will not cut. Already the model is removed. So I just let us see once more, or we have any doubts, we will come back. So in some shapers, sorry, in some planners, you can have multiple tools. So though the animation gives only one tool, so there are some machines where we call as a multi-head planners. So in that multi-head planners, we will have more than one tool. That means this is tool head one. So you may have tool head two here, and then it can cut three places. So this is regarding that planar and shaper. So if you have anything to ask, we will have some questions. So the shaper and the planar, the difference is both are to machine flat surfaces, but in the shaper the tool is moving, in the planar work is moving. So that is one major difference. Another one is feed rate. Feed rate is given there to the mark, whereas in the case of planar, tool feed rate is given to the, and planar is for very big workpieces which are flat, and say a few meters, as I said, in the so the size of the workpiece is enormous, and that type of machining, wherever it is involving big workpieces, we have to opt for planar. If it is small workpieces, we opt for shaper. Same purpose. So both of them will have the same surface characteristics, metal removal rate, etc. But in the case of a planar, you can adapt multiple tools. Uh, you can also adapt multiple tool head for taking cut in the reverse direction, or cutting in the reverse stroke. So that is the basic difference and applications wise. Yeah. Is it clear? If it is clear, we move to next type of machining. Is it okay? So if it is okay, then we move to another machining, that is broaching. So before going to the broaching is a very specialized operation. Let's see what it is. So broaching is a precise process for mass production of complex geometry. So the statement is very broad. That means it is very specialized machining process where you need to have complicated hole shapes. That means what is complicated? For example, this workpiece, the one which is shown here, the workpiece that is shown at this point. Say for example this one. So if you see this workpiece, this type of shape, can you machine with any other? I mean, with the process which you have known so far? Can anybody help me to identify, if suppose if this part is given to you to machine, or to propose, what are the operations or what are the machines that can be used to get this work done? Can anybody tell me, as per the knowledge which you have just so far? The piece that is shown there. Anybody can you use any other machining? Suppose if that object is given to you to, the drawing is given to you to prepare, what machines you propose to do it? Turning operation on lathe. Turning operation on lathe is only able to do optional turning. Internal you see, internal surface is not a circular hole. It is having some gear shape, something like. So yes, it is to some extent. Tash Hazim is correct. It is possible. I don't say it is impossible. It is possible with lathe, but with some difficulties. That means you can do external surface machining. Everything can be done. Internal thing also can be performed using what operations? Can you, if you can give me operations, that is, then you understood very clearly. Mr. Tash, you are partially correct, but you need to choose what process to make internal shapes. Internal shape is not a turning operation. Internal shape is not turning. What operations you require for internal profile? Internal profile is a something which is facing, is not internal facing. No. Drilling for hole, yes. Move iron, yes. Drilling, boring, yes. Boring is also correct because we analyze the hole, and then you want to have that shape. So drilling, boring, correct. Drilling you require to make hole, boring, and then you require external um, additional tools for boring, because the boring is only to enlarge the hole. Boring part. Boring at a point. That means you can do it. Yes, actually with drilling and boring is possible. So if you want mass production, and then if you want to make many objects, then if you can do it with the drill, with what you call machine, lathe machine, but you require Many tools, drilling tool you require boring tool, you require facing tool, you require turning tool, you require, and then reaming to extend that hole. So many tools are required, so many operations to be performed. Yes, it is possible with lathe machine, but with different some limitations and also very slow production rate because you have to change the tools. So in that case, in specialized operations where you wanted to manufacture say 100 pieces of that in one shift or something like that, then we need a special machine. So that is what we have here. Let us see how it works. Reamer. This is called, sorry, broaching, not reamer. So in the broaching, the process is high metal rate, that is advantage, and then very good surface finish, and then dimension control. But it is expensive because the tool itself is very expensive. The tool, if you see here, uh, the, the diagram here, this is the tool, and these are also the tools based on the shape you want. You want a circular shape, then you go for this. If you want uh, some farming shape, you go for this. And this is another tool. This is another tool. So what is the difference in this tool is this tool, if you see here, this is a circular tool. You have until progressively enlarged dimension. For that means this tool, the tooth here is say for example D, it will be D plus delta. It will be D plus 2 delta. It will be D plus 3 delta. That means 3x. This is D plus something. This is D3 plus something. This is D4 plus something like that. So it's slowly tapered, and means the number one tooth is number two teeth is bigger than two, three is bigger than two, four is bigger than three, number five tooth is bigger than four, like that. So this is staggered. This one, why this what you call something you can observe here, some dots like thing. Those are actually to break the chips because it is going in one stroke. Then alternative smooth break. This is here. So you see the teeth are slightly different. Smooth. Then uh, chip breaker, and then afterwards smooth finishing teeth. The last portion of the tool will have smoother and very narrow increase. Narrow increase means if this is T, this will be T plus not X. This is T plus not X. Like that, it is slowly increasing for finishing of it. That means, as a whole, the tool looks like a saw, which is increasingly depth of cut for the tool. So, if one pass of the tool, the required shape can be performed, uh, can be achieved. So, with one pass of the tool, you are going to get the shape of the profile. If you want, so for example, in the broaching, you see the broaching tool here. The broaching tool here, say the magnified view. This is actual tool how it looks. The previous figure tool is like a rod with so many. If you zoom it on to the metal cutting aspect of tool, so how it looks. This is teeth one. This is teeth two. Teeth two and teeth one is having an improvement of something. Say delta. And then here teeth two to teeth three is slightly deeper. Teeth three to four deeper. That means what happens? One will cut here, two will cut here, three will cut here, four will cut here. That means once it is passed, then obviously your depth of cut is from here to here. That is four times. So broaching is a machining operation that involves use of multiple cutting tools move linearly relative to the workpiece in the direction of the line. So this is the tool, and it is moving, and it cuts as it goes inside. So some of the shapes that are possible with broaching, for example, if you want rectangular cut in the previous thing, suppose you want a rectangular cut here in the drilling is only to make Whereas if you want a specialized shape, and then also we want normally to fix the gear wheels, a key slot. This is called key slot. Then we can go for this. Of course, key slot can also be performed by other processes. This is a specialized one. So here, if you want a hexagonal hole, if you want a triangular hole, or if you want a star-like thing, which is normal cuttings which we learned from lathe milling cannot not working. This is like a semicircular hole or a star-like thing. So this is now you can assume the application. So this kind of a hole you require in a gear or this is very normal. This is we normally very so only KSAT we can do by other means like boring something like that, but this is not other shapes are not possible with boring. So broaching is such a special kind of machining. So how it looks, let us see. I show you one video, which is animation again. So let us see this animation and understand how it looks. So this is the broach. Suppose if this red color one is the broach, which is having a portion called pilot. The initial end of the tool is called pilot, and there is one other side that is called rear pilot. This is front pilot, and say this is the component. The blue one is component, which you wanted to have a circular hole is there already. You wanted to have different hole as we show here. Something, suppose for example, you want shape like this. So some shape like this can all be possible with the broach of that shape. Then this is tool holder. It comes here, and then the tool is pulled through that. So here you see the tool will come and sit here on the holder. Once it is sit in the holder is now tightened and then pulled through that. Pulled through that, when it is pulled, it is already tapered. You can observe here. This is the tooth is slightly increasing, and then it is tapered shape. So it is like this. So as it goes like this, once it is comes the end, the other pushing retriever head is removed, and then by the time it passes through this, obviously it will cut the internal shape, and the shape is formed here. Remove the workpiece, and then it will come back. It will push back. The tool will come. Piece next workpiece comes here, and then next. So this one is actual, the one which we shown here previously is animation. Now let us see the actual cutting. Actual cutting, for example, here you see the material, say some steel, which is having only circular hole. But I want that circular hole to be some shape which I have shown previously, to fix the gear wheel or to fix onto some slot. So if I want machining that shape here, let us see how the approach can be. So here you see the broach is inserted. So this is the broach. So you can see here the tooth progressively increasing order. Pilot now there is no teeth here. This is called pilot. That means smooth one. Once it crosses pilot, now from here it will start cutting the material. That is why the fluid is now on. The fluid means cutting fluid, which we discussed in the previous classes. So the cutting fluid is to smoothen or to take away the heat that is generated during the cutting. So now So now the broach is inserted, that means it is cutting the shape. Once it is done, see the shape on the. So you can see here the cutting fluid, how it is applied there, because it is the participating the cutting here. So it is immersed in the cutting fluid to make the chips taken away, as well as to take the heat away. So now you can see the shapes that is formed here. This is what you call the end, the one which is shown in the previous diagram. The shape, inside shape is stepped grooves. Stepped grooves. So this is stepped grooves. Next, it is what is called um, rough machining. Now we can use another broach to make the smooth cutting. That means you see here the edges are not very smooth and very accurate. Then we use another tool to make the finishing. So see, now you can see more closer view, and I think you are able to see the shapes here, the shape that is formed here. Now at this point it is here. So now we apply another broach to make that. I mean, so that is regarding the broaching. So this is again animation. You can also have linear broach, something like this, like what is shown in the previous application is a circular broach to make circular objects, circular holes and grooves that required. You can also have external cutting with a straight broach, something like that, like gear cutting or gear wheel, gear broaching, etc. This is called gear broaching. So I think you got what is broaching and any issues there. Is it clear? Is it clear? Any yeah, broaching I think is now you can appreciate, because the broaching actually is a specialized operation again. Here the cutting tool is expensive, because you know the cutting tool is very lengthy, and then so much of gradual increase in cut means preparing a cutting tool is difficult here in this process. Getting tool is very difficult. Getting tool is expensive, but operation performance is very easy. Just you have tool, just you run it, finish. You get the suppose barring the expenses. When I ask some this question, some of you, Mr. Dash, told that this can be done on turning. Yes, it is done. If you see here, it is a matter of quick few seconds to get that shape. In case of a turning, it is you need to change some 5 6 tools, and then not sure whether you get correct accuracy or not. But here you can get, but the thing is here the tool is expensive, and the tool is expensive, but there is no problem. If you is a mass production, that means you wanted to do 100 pieces a day, something like that, then no problem, your tool cost can be taken care. Only if you want one job, yes, you have to go for lathe, you cannot buy this machine. If you have 100 jobs per day, you have to go. So with that, we move to another very versatile machining which we use every day. Let us see that other operations which we use every day. Maybe yeah. So other very important operation which we use is drilling. So drilling before drilling, let us take some break. We already have 1 hour. Take some break. So in the break, I propose two things to you in the break. One is we have a quiz coming up in the you learn. We're not in the MS Teams, just like what we had in the last week. So you answer that quiz. That is only 5 minutes. It will appear in 1 minute now. It will appear now. So you answer that. After that, you answer SSRT, self-reflection tool for manufacturing technology course. Do it now. We will meet again after 5 minutes, uh, maybe 10 minutes because you have to answer SSRT also. So we will resume our discussion at 5:05 to discuss quiz regarding quiz. For that, you can finish your quiz as well as SSRT. Both. And when you are ready, some of you tell me, then we resume. So please answer your SSRT. I will check SSRT after this class. I must see all your should be answered because you forget afterwards. Okay, I told you you understood. I think you have one quiz in the MS Team. You answer it. Takes 2-3 minutes. After that, you answer your SSRT also. Take 2-3 minutes or 5 minutes. Then we'll back as well as our quiz. Any doubts? So I think we are done with your quiz. Is it finished? Yeah. So if everybody is done, then we move to our lesson. But I don't see any. This U campus also. You try to finish now itself. Just we will wait another 4 5 minutes because now anyway we break. So just log into UCampus and then answer the survey MEB 10133 manufacturing technology. Because last time cycle one nobody answered, so I must ensure this time everyone should be completing your survey. So please complete that survey SSRP2 UCampus. Log into UCampus, press a survey and choose the subject MEB 1033 manufacturing technology. Use my name Srinivasa. So then you put your feelings there, uh, whatever it is. So, but I want the everybody to participate. Hmm? That is the motto. Please do it. Huh? So if you finish, then we come back to the lesson and see any topic. I wait for you for 2 3 minutes again. Maybe 5:15 we start the class. Another 3 minutes, please answer that survey and come back. I want to see all of you to participate. Okay, so those who are now doing, let us continue our lesson. So those who have done, thank you, and then others, please do it at least after the class. If not now, after the class, you can do it. So we will continue our lesson. So before going to the lesson, I think the quiz is already answered. Most of you, all of you who are here. So I don't think any doubts in that in the quiz. So we can discuss. Just let me go through that questions. If you have any question, then you see. I think the first question is, are you able to hear me now? Because I am looking at other window. So mostly I think you are able to see. Let me open that window. Yeah, you are not able to see because it is not shareable. Anyway, I will share the normal window, and then coming to this part, which of the following cutting tool has the highest hardness? I think. Okay. What is the first question answer? That the first question in the quiz is, which of the following cutting tool has highest hardness? The answer is ceramic. Throwaway tips are used because some of you might have put something, but what is the correct answer? Throwaway tips are used because, can anybody give correct answer here? Because some of you are wrong there. Actually, I should have given you quarter mark or half mark for other answers, because all the above are correct. So those who put A, B, C, D, A, B, C, maybe partially correct. So you are entitled for half mark or quarter mark if you miss that question. Other answer is, which of the following tools is most suitable for very hard and brittle materials? So which of the materials is most suitable for hard and brittle materials is carbide, and which of the following material can be used for coating materials? Is there any answer? So there is one material that is given, titanium something is given in the multiple choice. I found one small glitch, but somebody is how are you correct? Let me see. So some of you are 5 out of 5. So though that is correct. Then which of the following tools is most suitable for very hard material? Carbide. And which of the following material can be used for coating on tools? TICN. And then ceramic cutting tools are very brittle. So some of you are scored all 5 marks, but some of you are only scored 4, 3, very few. Okay. Let us come to our lesson. Never mind. So even if you miss this one also, don't worry, because this is not a very well, the weightage is only 1%. So we have so many quizzes. So as and when you miss one quiz or 1 mark in the quiz is not a big deal. But whether you participated or whether you revised it and whether you learned something or not is the important. Okay. So let us come to our lesson. I think you are able to hear me, and everybody is back on platform. So let us see the other operations. So the other operations are drilling, reaming, and boring. So everybody know what is drilling because it is a very common household operation also. But in the industrial context, different weldings are there. Different drillings are there, and they are called reaming, boring, and so on. So process to make holes is basically drilling. So process character, what is that is high MRR, that means metal removal rate, that means high metal removal rate. Medium high surface, that means very high finish cannot be also possible, or medium surface finish. And dimensional control is also medium to high, not very high. So why let us see why drilling is not so very surface finishing is medium. And so drills are different varieties. One is twist drill. You can see this type of drill at many places in your house or everywhere. So this is very common, twist drill, where the drill is in the form of a helix here. The profile here is helix. And we have another drilling which looks like a milling machine, milling cutter from front end. That is from here. If you look at from here, this is like a milling cutter. But if you see on the floor, that is again drilling. So this is called core drilling. What is the purpose is to increase the existing diameter or existing hole. And another drill is a spade drill, which is like a very sharp corner and then a spade. So it is normally to drill holes in. You can find this kind of a thing in wood to drill holes in wood. So in a metals, somewhat rare, this kind of a spade drill. And a step drill for drilling stepped holes. That means until one time, one diameter, next diameter is D. So you see here, this is D, small d, this is capital D. That means two holes. That means progressively narrow inside the narrow. So inside hole is small, outside hole is big. Then countersinking. I show you what is countersinking. Countersinking is enlarging the already drilled hole at the edges to accommodate the screw heads. Screw head, you know the screw. The screw will have a head with some notch to fit your screwdriver or to fit your tool. So that is to sit on this. We have this is called countersinking operation. Counter boring operation is also a boring itself. Actually, boring is to enlarge the existing hole. Counter bore is also enlarging the existing hole only at the edge to make it as a seat for bolt heads, nut heads. So this is to seat the bolt head. So this is called counter boring. And reamer is also a special kind of a tool which is also used to enlarge. It is something like you see here. There is this is the tool which is insert. Insert means detachable thing like. So the insert at the periphery, and a typical drill which is called center drill just to mark the center on the pieces. That means it is only having one tip. And we have gun drill with holes for coolant. What is gun drill? Means you see here the drill is very long. So it is actually the name indicates this is golden days to drill the gun barrels. You know the gun barrel is some length half meter, 40 centimeters, something like that. So that to drill that kind of a deep hole in the barrel. So that is why this is called gun drill. Obviously, this is a drill with lengthy flute. That's all. So this is different drill bits and drill operations. Uh, so in drilling, Actually, the drill tool has a nomenclature, something like that looks like this. Actually, this is the full form of the drill. This top portion is called shank, which is going inside the holder, or sometimes taper shank also there, just to fit into the collet. So the shank can be either tapered shank or a straight shank like this. And after the shank, we have a small gap that is called neck. After the neck, we have the actual drill tool, which is made up of helical flute. Helical flute means helix. It starts from here, it goes. So this is helical, which forms. If you look at from other side view, the side view looks like a profile like that. So this is on the side. So when you look at the total front view, the front view is like this, side view is like this. So the drill diameter, actual diameter, though it is like this, but the drill diameter is the one which is the topmost point to the bottommost point of this helix. So this is the drill diameter. If you observe the drill, actually drill is slightly tapered towards the end. That means the diameter here is not same as the diameter at the end. It is slightly tapered to accommodate the chip flow as well as to avoid the blockage. Suppose if the whole tool is of the same diameter, when it goes inside the material, it will stuck there because every surface is touching the surface of the work. So to avoid that, slightly taper is provided on this, which is not visible for naked eye from any magnification, but in micron level it is like that. So, and again here in the drill tool also, we have the same nomenclature, which is something like our single point tool. We have a relief angle, we have helix angle. Helix angle is the angle of the screw, and then cutting edge, and the one which is the this point is called the chisel, which actual first point to hit the material. Chisel edge is the one which hits the material in the initial stage. Then the fruits come into picture, and then cutting edge, and then they start removing them. And then this geometry, just you know the terminology of the geometry, because we are not working with geometry, but you should know what is foot, what is the length. So the diameter of like that. So what is the properties or the features of drilling is soft materials. That means small point angle. For hard and brittle materials, we go for big point angle. So for machining soft materials, you can use small point angle. Point angle means what? You can see here point angle is this. That means the angle between the two cutting edges is called point angle. So this point angle is normally 105 degrees, 105 degrees, 100 degrees, something like that. So for small softer materials, you can go for small point angle, which means that tool is very sharp. Whereas large point angles are required for brittle materials and hard materials. They said which is normally 105 or 113 degrees. 113 degrees is the hardest. Then length to diameter ratio. Normally that is less than 300. As I said in the gun drilling means the previously shown the barrels which are of some meters. In that case only L by D ratio. So why when we call it as a gun drilling bit or a normal drilling bit or a lengthy drilling bit, why we say or we decide by L by D ratio. That means what is your diameter of the hole and what is your length of the tool. Length of the tool is 300 times more than the diameter of the tool, then that is called gun drilling. Other than that, it is called normal. Very small diameter holes, example 0.5 mm, cannot drill. Can anybody guess why? That means half mm. You might have seen some small hole, small drill for some thing or some jets of 2 mm, 3 mm, make the holes for nails or screws. So zero point 0.5 is very thin. Huh? 0.5 maybe that type of hole. So what is the reason? Is it not possible? Or it is possible? Because zero point 0.5 means your drill tool must be having zero point 0.5 less than zero point 0.5. You will come to that. Why? What is the actual dimension of the tool when you want 10 mm? A tight dimension control drill. So reaming is actually nothing but another drilling, which is to have a finishing process. Reaming is not a different process than drilling. Drilling is to make initial hole. Say you want 10 mm diameter hole. You take the 10 mm diameter drill and then do it. You get 9.5 mm as the hole, not the 10 mm. The reason is, I'll tell you. And then later we use another tool called drill reaming to make it exact 10 mm if your application is very accurate thing to be maintained. Then spade drills, large and deep holes. This is actually for pen or soft letters. Okay. Countersink counterbore already I told you what is it. It is to accommodate screw and bolt heads as we see. So anyway, I will show one more thing. So basically, drilling is a process of producing round holes. So the definition of drilling is process of producing round holes, solid material. Enlarging holes is also called boring, but it is also drilling when you want to have a 50 diameter hole. You may not drill directly 50 diameter hole. We drill first 40 25 then enlarge it. So that is the contest here. Enlarging bit by a 1 half is called boring. Even reaming is also for the same purpose. Reaming is a process of improving the quality of already drilled holes. As I said, you want to, your intention is to drill 10 diameter, 10 diameter hole. And you take a 10 drill and drill it, you get 9.8 or 9.6 or 9.7. Now get 10. If you take more than that, your hole will be more, and then you cannot reduce the already drilled hole. You can enlarge the hole, but you cannot fill the hole. So that is the problem. That's why we always drill half mm or zero point 0.1 below the required thing, and then we will make sure that it is only the required dimension. For that we use it. So drilling and reaming are performed in a drill press, although other machine tools can drill streamers execute all the secondary field. So this is regarding drilling and thing and how it looks. It looks like this. So you have a drill pressing against the bar, means you are penetrating the drill into the material. So this is this chisel edge which is participating in the cutting. As it is advanced, so it will come here. So the material here is removed through the chips, and the chips will come out through this passage like the fruit. So this, if you see the fruits, they are making a gap here. The gap is to they will guide your chips out of the hole. So the material that is removed from this area to be come out. Otherwise, it is not like our pre-lathe machining where the chips go to the air and then fall onto the floor. It is not like that. It is the material has to come out through this drill bit only. So that is the one thing. And then diameter, as I said, diameter of the tool, say the diameter of the hole which you want to make is capital D. So your drill is of small. Small d is radius. Okay. So you are picking a tool. As I said, if you want to your intention is to make the hole of diameter D, you pick a D diameter hole. a D diameter drill, and then drill it, you end up with less diameter or sometimes more, but some more is very rare. Less wide you will see. Position of the twist drill after motion. So this is the forward movement or penetration into the material is called feed rate. Feed rate F per millimeter per second. So that means the progressive movement inside the material is Fm, that is feed rate, and the tool is rotating at a some velocity, that is say high 1000 rpm, 600 rpm. So that is what the drilling. If you have any doubts drilling, let us take the doubts. Then I ask you one question. The question is, when you want to drill 10 mm hole, you pick the 10 mm diameter drill and then drill it. You are end up with 9.99, 9.8, and so on. That's what I commented. Why? Yes, the drills can be resharpened also. Yes, it is possible to resharpen, Mr. Cash. It is possible. We do it like that. It is possible. I think now my voice. Okay, maybe. How is it now? So, can anybody tell me what is the reason, possible reason? Yes, the entire, not only tip, the hole that is made is less than something, say 9.9 or 9.995, not exactly 10 mm. Why? Because what may be the reason? Just tell me the some reason. What could be the reason? Though you took the 10 mm hole, actually you took the 10 mm hole at 10 mm drill bit and machined hole, but after you make the hole and take out the drill and then you measure with vernier calipers, you will end up normally in most of the cases, most of the materials. There are some exceptions. In most of the materials, it is 9.995 or 9.5, 9.99, something like that. Means 0.5 mm less. How much less? It depends on material. Again, I give you clue. How much less? It depends on material. So the what could be the reason? You insert a 10 mm drill. It should make 10 mm hole, but it is not. After you take out the drill. So I gave you clue also. It depends on material. In some materials, it is more than 10 also. Some conditions, actually not materials. Some conditions and materials also. So what could be the reason? Uh, so what happens when you perform metal cutting? What happens there? The tool is heated up. The material is heated up. That means the material is at high temperature. Is there any explanation from temperature? I am giving you a clue. Temperature is the reason. Temperature is the reason. Can you at least now? Can anybody answer how the temperature make it wrong dimension? Am I audible or not? I'm not audible. Hmm. So material expand, yes, that is one reason. Yeah, because Mr. Tash is only listening, or nobody else is listening, or what? So heat, how can heat? He says expand. Is it correct? Normally, as we learned in casting also, in the casting also, I you whether you remember or not, in casting, You want something, you make pattern of more size. Why more size? You make pattern slightly more size than the required object. Then your object is contracted and you get correct. I mean, you get right dimension. Is that we discussed in the casting? In the casting, you required a pattern, and that pattern is slightly more than your cavity that is you intended to get it. Why why we give more cavity than what we require? Because after contraction it will come to some reduced dimension, because the material at high temperature occupies more the expanded. When it is cool to room temperature, it will contract, and then the dimensions are little bit lower than the expansion mode. So same case here in the drilling. When you drill it, obviously it is heated up. Of course, you are supplying coolant and removal of heat as much as possible by coolant. Everything is done. Still, the material is heated up, because of which, when the tool is inside the material, it is 10 mm. When you remove the tool, the material starts cooling. That means the hole is shrinkage. Because of the shrinkage, now your diameter is not, actually it is 10 mm. When it is 10 mm, it is 10 mm. When it is hot, when it is room temperature, it contracts. Here it depends on material again. The material has some materials, if it is say normally all materials, when it is shrink, obviously they shrink inside. I mean, they bond together, and because of the bonding, the whole diameter increases normally. But if it is increases, then 10.5. It will not be 10. It will be 10.5. So this is the property. Sometimes you end up with more than 10 mm. Sometimes you end up with 9.9. So in drilling, based on the material on which you are working, you should take a drill bit of, that is why tolerances. They say the tolerances. Say based on that, normally we never, if your intention is to drill 10 mm hole, we never use directly 10 mm, because there is no guarantee that it will end up with 9.9 or 10.1. If it is at ended with 10.1, you cannot make anything, because you cannot fill already drilled hole. Maybe you can enlarge by some. If it is 9.9, no problem. You can enlarge it with reaming, boring, something like that. Yes. If we suddenly cool the material during the operations, would the material and the drill undergo thermal shock? Yes, definitely. It will go shock if the temperatures are very high. Very high in the sense, say if the temperature is too hot, then if you suddenly apply, that is why we apply coolant from the start of the machining, at the start of the machining, not after machining. So if you see, if you observe the previous broaching tool, etc., when I saw some video, initially the fluid is not open, but when the moment the tool is in touch with the material, you start pumping the coolant. Because if you pump the coolant after machining or after some time of the machining, already it is hot. If you pour, as you said, it may develop a crack, particularly if the tools are brittle, because tool materials, something like ceramics, are brittle. Those are they will develop crack. So you are when you want to use coolant, you must use it at the start of the machining, not at the middle. So this is the reason. So we use the reaming for to make that corrective action. So whenever you have some diameter drill to be hole to be made, then you go for a tool which is slightly less than the required diameter, and then enlarge. That is standard practice. Because by standard practice, because if by chance, if the hole is more than what you want, cannot. You have to throw it away, the whole piece. Cannot make it. So that is the practice. So that is why we use reamer to make sure that we want the exact dimension. And another thing is why the tools another aspect of it is the tools may be subjected to, because the drill is a kind of a overhanging type. That means the load is what you call the overhanging type. So therefore, the drill bit may subjected to kind of a vibration, and then the bending. So the vibration and bending of the tools, drill tools, I'm talking about drill tools, make the hole somewhat inaccurate. I am not explaining any slide. I'm just giving general comment on drilling. Okay, Mr. Chair. It's not about slide. It's about the property. So we come back to our slides again. We are running out of time. So this is cutting conditions in drilling, which we already have seen. In case of a boring, you see the boring means, you see why we need boring and reaming is, as I said, we don't, if your intention is to have the D diameter hole, we don't drill, we drill something slightly less than the required diameter, and this small d is made by boring tool. That means this is not drill, only you just remove according to this is don't think this is not something like 1 mm, maybe half mm, 0.5 mm, 0.25 mm, some 100 microns, 50 microns, like that also. So this is to have a boring operation. Boring operation is means an operation quite similar to turning, but is to enlarge the existing hole. So this is cutting conditions in boring. Reaming also is in the same concept, just to have the finishing operation. So if you see this different drilling operations like our turning and a lathe, we have different drilling. One is drilling, bore drilling, step drilling. Step drilling means you see here there is a diameter of D here. There is another diameter of D here. Then counter boring, which I show you to accommodate the tool, to accommodate the bolt heads, and then counter sinking to accommodate the screw heads. Screw head means tapered. It is tapered here. And then reaming is to enlarge the hole. Actually finishing, not enlarge means it will not enlarge any dimension. Only to make finishing of few microns is reaming. Then center drilling is to make point center. This is only for marking purpose, not to any holes. Center drilling is just marking purpose. Then gun drilling is large holes. When you want to have large holes, the gun drilling will have this dotted line is a hollow portion through which you supply the fluid, cutting fluid. Because cutting fluid, if you pour here, it may not reach inside because it is very lengthy of 0.5 meters, as I said, like 10 barrels, etc. And D by L ratio, L by D ratio is very high. So if you pour drilling, cutting fluid here, it will not reach. If you drill certain extent, we apply cutting fluid by external thing. Otherwise, we use a as an internal line to the drill itself. That is the drilling by gun drilling. So the explanation is given here. What is drilling? The thing already I mentioned. So only thing is here. The reaming provides better tolerance and surface finish to initially. So this is the difference. Slightly increases the diameter. So it is not very high. You can say finish. Finishing is called reaming, drilling, drilled hole. So gull drilling already told, L by D ratio more than 300. Center drilling is used to start a small punching or marking type hole. This is uh, just to ensure that the remaining tool inserts properly. So center drilling is just to make sure that at exact point we we machine the drilled hole. So this is for marking. This is something like marking. So all these things I show you on video again. These operations, how it looks, Though the figures are enough to explain this thing, but we have first-hand information because we are not visiting laboratory. Let me show you here. You see here, this one is drilling, normal drilling, making holes on the flat surface. So this is how the you see here the making of hole and the chips are coming out. Of course, no fluid is shown here because it is only a small depth. This one is reaming. Already we have drilled holes, and then we have a tool called reamer only to finish the tool to the required diameter. So reamer is like not like our drill, no what you call helix, something like that. This is just straight. So those two are the drilling and reaming operation. Now we see other operations. Tapping. Actually, tapping I have not introduced you. Tapping means making threads, inside threads, external thread, not internal threads. We can say making internal threads is called tapping. So internal threads can be obtained like on a lathe machine also. But here this tapping is made by a tool called tap tool. That means process of making internal threads is called tapping. So for that, a tool called tap is used, which is having the thread profile, and then the thread profile is created here. So the drill hole is already there. Now the drilled hole is made up of making threads. So why threads? To fix some bolt or nut. So we want to have threads in this here. So the thread is created by a tool called tapping tool. Tapping means making internal threads. See here the tool is having the threads here. So those threads are formed there. That means it is a form tool. So this is the form tool. This form is formed on that. Here that is the tool that is inserted. Now can anybody tell me what is this operation? This one? It is the. Can anybody tell me what? What is this one? This one and this one. At least this one is very clearly visible. What is this? Can anybody tell me the first one from that side? Enlarged diameter, no. Countersunk, yes, somewhat correct. Countersinking, somewhat correct. Yes, not completely correct. Countersinking to make the bolt to accommodate the seats. Countersinking, yeah. The other one, third one, can anybody tell what is third one? Of course, it is not clearly visible. Okay, I will show you the close up. So now you tell me this one, what is this one? So somebody answered. This one is countersinking. What is this? Maybe are you able to visualize what is it? okay. It is not enlarging. So what is it? Can anybody say what is it? Counter boring. Yeah, counter boring. So let us see, complete that one. Just watch until the end. I will come back after ending because we are. So this is counter boring. That means enlarging only at the end to accommodate the bolt heads. Thinking to enlarge the hole at the edge to accommodate the screw heads. Screw heads. Bolt head is a round one. Screw head is also round one, but tapered. So this is the final one is counter boring. You can see here. This is counter boring. This is counter sinking. This is tapping, and these are the hole drilling, and this is reaming. That means this drilled hole is finished to have this diameter. Actually, the diameter which we want is this one. But when you have initially you cut this is something called rough cut, and then smoothen it like this. So this is drilling, this is reaming, this is tapping, this is countersinking. Sorry, the last one is countersink. This is counter boring. So this is what we can observe from different drilling operations. So uh, maybe we can stop here. Any questions here? If you have any questions, we take questions. Any questions? No questions? Okay, if no questions, we stop here because we already, I think we are 6. So we will continue in the next week. Before next week, we have next exam in next week. So next week, exam on Monday, same day, this day at 4 p.m. That means during your normal class time, you have exam 2. So exam 2 will have 3 questions. One from cutting tool materials, either one from turning and lathe, etc. That means not previous metal casting. Already one question from metal casting, question from turning, the cutting tool materials, one from what is machining. Okay. Machining, just let me know one thing. Cutting tool materials, cutting tool. Any doubts on? Yeah. Any questions? So I think we may limit our exam to only for metal cutting. Casting, okay. I may exclude casting for final exam. Okay. So we try to cutting tool materials, cutting machine, metal cutting, and until last class, not this class. You can exclude this class also. So our exam 2 will have metal cutting tool materials, and fundamentals of machining. So that means fundamentals of machining, machining process part 1, machining process part 2 until last week class. So that is our exam 2 syllabus. Metal casting, I may give you some, of course we have some quizzes also. Our final exam, we will have all 4 things, all 4, metal casting as well as machining, welding and metrology. But for final exam, we may limit our discussion to cutting tool, the fundamentals of machining and machining process. Okay, so read this one very carefully. Exam is on next Monday, that is week 11. Okay, exam is on 23rd November. So I mentioned here, so exam is 23rd November at 4 p.m. and it is for 1.5 hour, 90 minutes. After that, I think next week maybe we don't have class. We will have exam directly from 4 to 5:30. So you can log in to ULearn and then you can see the questions there. I think you already attend exam 1 and the other exams in other courses also. So so you know how to log into ULearn and then how to answer the questions. But the questions you upload your answers at the right time, and that means at 1.5 hour. The given time is 1.5 hour. So that thing. Any questions on this? Other thing is, as I mentioned, just you answer the SSRT survey, if not already now, because some of you are answering network is not good like that. So that is the survey is about teaching. So please, the other survey is about every day. That is poll for MS Team connectivity and so on. This survey is about lesson, how you achieve your goal in the lesson or not. So, so the two are different. SSRT is regarding the course. You whether you understood the course, whether the lecturer is good in the course or so. So on that. So please answer SSRT for manufacturing technology today itself, because later you forget and I forget, and then finally other subjects also will come up for the same thing. So you try to answer today itself 1033 manufacturing technology course SSRT. So, right. Anything else? I think we can stop it here because we are already running at around 6:10. So no questions. We will stop here and meet again week 12, not week 11. Week 11 you have exam. So attend the exam. After the class, we want, we can meet. I think you are busy with the exams this week. I mean next week. Okay, next week we don't have class. We meet in week 12. Week 11 is exam week. Okay. Yeah. Right. So that's why please answer SSRT today itself, because next week we don't meet. After week 12, we are in a hurry to finish our remaining topic. So let us do it now. Please do it now itself. Okay. Yeah, okay, right.